Okay, where were we? So we discussed this one. Example of another kind of question then, again, quite similar to year 12, but with I, J, and K instead. So 2a, well, let's find 2a then. 2a should be 4 minus 6, 10. Minus 3b, well, what is 3b? 3b is 12 minus 6, 0. So that is 2a, that is 3b, so 2a minus 3b. Okay, let's just work it out while we're here then. So 4 minus 12 should be minus 8, minus 6. So if you have the thing and you take away that thing, then that will disappear. And 10, take away 0. So this is 2a minus 3b, and it's parallel to this. So this is equal to some multiple. It might be like 2, or it might be a half, or some other number. It doesn't have to be a whole number. It could be a fraction, bigger than 1, minus than 1. It doesn't matter, but this is the way I would write it. I would say the thing is equal to a multiple of the other thing. 4i, well, that's a 4. J, there's no j, so 0 minus 5. Well, you might be able to see it already. What's this one here? Pick any line to make an equation if you're unsure. Minus 8 equals 4 lambda, so lambda equals 2. What do they actually want us to do on this one? Oh, they just want us to... I think this question is a bit incomplete here. I think they want us to show that it's parallel. Okay. So what we're doing here is we're showing that they are, one is a multiple of the other because they're the same thing. It's just been multiplied constantly for I, J, and for K. Okay, so nothing really brand new there. Something though that probably is a little bit new is this part here. Okay, so this is the magnitude of a vector. So imagine some I and J and K will give you a number here, all right? And this could be the hypotenuse. You could draw some triangles. So what do I mean you could draw some triangles? I mean, you could make a triangle with the Z axis. You could make a triangle with the Y axis, a right angle triangle. You could make a triangle with the X axis. And by deciding which axis you want to make a triangle with, it will work for all three of them. Okay, you can find out this angle here. So sometimes we get asked about what angle does that vector, and when we say that vector, we're looking at the magnitude, which makes the hypotenuse, okay, have with the axis. Well, we do this, and labeling your triangles, that's opposite, and that's the hypotenuse, isn't it? Sorry, no, we're not talking about the opposite. We're talking about the x-axis. So we're talking about the adjacent. So A and H is Ka, isn't it? What about if you did this one down here? If you looked at this angle, you would have A and H. You'd have Ka. Whichever way, you always have Ka. So you use the cosine, okay? You use the cosine in a SOHCAHTOA right angle triangle to find the angle that a vector makes with one of the axes. So depending on what axis you want, so cos theta, this is the angle with the x-axis, will be equal to, well, A, this is the adjacent side, over the hypotenuse. The hypotenuse is the same as the magnitude. So that looks very, very complicated there, but all that's really saying is you do SOHCAHTOA and you'll always end up using cosine if you want to find the angle that a vector makes with an axis. So one more example. What angle does this make with each of their axes? Each of the axes. So if you wanted the angle with the x-axis, that will be the same. If you want the angle with the y-axis, it will be like that. And with the z-axis, it will be like that. It depends which axis you're talking about. So you just use that letter. Okay, so it's the same. And those are some answers there. Notice that they all use the hypotenuse, don't they? Because the hypotenuse doesn't change for the vector. But depending on which triangle you draw, the adjacent side will. So that's sort of a new one there, talking about angles that they make with the axes. Pause the video and have a quick go at these two questions here, and we'll just quickly talk about them. And then it will be time to have a go at some of the questions from the book. 12A has pretty much been skipped here. It's a recap with 3 dimensions. 12B is a little bit more interesting. Pause the video here and have a quick go. Okay, so we've got some vector and another vector here, and it talks about like a triangle. Okay, position vector is a bit like being given a coordinate. Okay, so position vector means this is the vector from the origin. So this is the same as the coordinate of 4, 2, 7, and this is the same as 3, 4, minus 1. Find A to B, or A to B, yeah, is by doing that. Find A to B and show that OAB is isosceles. So it's probably helpful, even if it's not accurate. 4, 2, 7, you just sort of draw something like this. 3, 4, minus 1. Now, I don't really know what this looks like, okay? But I'm just doing this so I can visualize something. So OAB, well, O is the origin. A could be here, and B could be here. How do I know what the triangle looks like? I don't. I'm just using this to help me think. So show that this is isosceles. Well, if it's isosceles, what could be true? Maybe they are the isosceles ones, but I don't know. Maybe it's those ones. So I need to find out what? I need to find out the magnitudes, because vectors do this. No, you want the lines, you want the straight lines, the distances, the length of the triangles. So you need to do the magnitude, and you'll need to do the magnitude of OA, OB, and AB, won't you? Because how else will you know which two sides are the same? If you do it, you find out that what? You find out that AB and OA are the same. So AB and OA is actually that one that I've just drawn there, but that's complete luck, okay? I wouldn't know that. I would have to work out each of these magnitudes. You also had find the angle with the axes, x-axis. So cos of theta with the x-axis is adjacent. Adjacent will be x over the hypotenuse. The hypotenuse will be the magnitude of the vector itself, which will be, well, what's that going to be? That's 4. That's going to be 1, and that's going to be a 1. So it's going to be about √6, isn't it? Okay, so we've got this one here. And that takes you to 12b.